this is not your introductory example. What am I talking about? Oh, we're trying to do the limit comparison test, and this video is not for note-taking. Don't believe me? Just watch. What? We're comparing it with the quotient of the leading terms. So what do I have? I have k to the 2/3 divided by k to the 3/2. And then I have k to the minus 5/6. I'm doing the limit comparison test, so I'm looking at the limit as an, the OG series, divided by bn, the manufactured sequence. If that equals a limit, then they both do the same thing. So now I'm going to do that same thing, and I'm going to take my an and divide it by my manufactured bn. Oh, there we go. And some of you may have heard that rhyme, that hum, that hymn. Dividing by a fraction is the same as multiplying the reciprocal. So, I want to get that 5/6 in that root. So I rewrite that in rational notation, and I get the same denominator. So I can rewrite that guy with the 2/6 so I can get that k inside, and that's what I'm doing now. So I have the limit with that k inside of the 2/6, yeah. And then I'm going to rewrite everything that I had out there, because I'm using my property of exponents. And here we go. Drop it on down. Right there. I'd like to remind you that 3/6 is the same as 1/2, and then I'm going to rewrite that denominator with the 1/2, and then I half, those exponents are the same, so I'm going to rewrite those in the same root using my property of exponents. Let me write that nicer. Okay, good. And here we go. So now we're looking at the limit when I distribute that k inside, and I'm going to rewrite all those guys with the 1/2. Now, what am I going to do? I'm going to go through and rewrite those guys with the same denominator so I can get them both to the 1/6. Because I'm using this property of exponents. All right. Rewrite those guys to the 1/6 power. And that's what's happening here, because I'm using that property of exponents. Now, I'm going to multiply those squares out and those cubes out. Right here. Because a binomial squared, that's the first term squared plus 2 times the first times the second plus the second squared. Using that guy. That's what we previously had. Now, let's go ahead and make it rain with that 3. That's k to the 3rd and k to the 3rd plus 2 to the 3rd. Because I'm using that property. If I have a fraction to the power, that's the fraction of the powers. Let's go ahead and expand out that trinomial in the denominator. I'm using a binomial expansion to the 3rd power. More specifically, this one. What was our original? It was this guy, and it expands out to that blue down there in the bottom. You're my boy, Blue. And then I'm going to distribute in that k, and that's how my exponents change. And since the 6th root is continuous, I can pass my limit in there. That's what happened there. And now, we run that limit, and that limit is 1, and the 6th root of 1 is 1, and that's fun, but we're not done. What do we have? We're using the limit comparison test, and since our manufactured series is a divergent p-series, then both series do the same thing. So by the limit comparison test, our OG series does what? Let me clean this up. Diverges. Una caja y una flor.